Hello and welcome back. My name is Calentronics. In today's video, we are going to take a look at integrations under a function of a linear function. That's function on a function. So here is the questions we have brought from A to G. So we are going to start with an explanation of function and then proceed with solving the question. So initially in our previous video, we are familiar with solving just normal integration. That's when you have integral of x raised power of what? Let's say x integral of x raised power of n. So here is just replace the x as what? A linear expression, such as integral of what? Instead of x, it become what? Ax plus b then raised power of n. So it's just normal procedure to be applied. It's just lettering some things. So we are going to let this x to be equal to this, and then we can say let this u to be equal to, let's say, ax plus b, and then we know that already this become what? Since u is equal to this, we can say integral of u power of n. So this will become what? Equal to this. So it's just the same procedure to be applied. So another thing we need to understand is it is often necessary to integrate one of this expression that we have mentioned, and then in our list of standard integral when the variable x replaced as linear expression. So let's take question number 1 and demonstrate its effect. So question number 1 says to integrate what? 3 that's 3x plus 2 raised power 4. So in our normal mode we are familiar, let's say x raised power 4. Let's say we're familiar x raised power 4 to be equal to what? X power 4 plus 1 all over what? 4 plus 1, which is what? That's plus c, which is what? X raised power 5 over 5 plus c. So in this case it's not the same. So since we're familiar with this, we can't say just we have 3x plus 2 raised power of 4 to just say let's 3 to be 3, let's say 3 just say 3x plus 2 raised power of 5 over 5 plus c. So it's not. So all you need to do is to just say, since we have this, we can let this linear expression to be equal to certain alphabet or to be equal to certain numbers. So we can let's say u to be equal to this. That is, we can let u to be equal to this, this. So you can say u to be equal to what? 3x plus 2. That's with respect to x. That's with respect to x. So since we say u to be equal to this, then our equation will become what? We can now say integral of what? Since the whole here is become what? U, so we can say u raised power of what? 4 then what? Dx. So here remember is u, but one thing you need to understand, here is u and then here is what? With respect to x. So there is no way you can what? Integrate the u with respect to x rather than to find what? Du, so that you can integrate u with respect to u. So how can we find dx, or how can you find du? So if we differentiate this, since we have what? You have u here, so we can differentiate this u with respect to what? We can differentiate it with respect to x, saying that du by what? Dx is equal to what? Since here is du and then here is x, so we can differentiate what u with respect to x. We can now say differential of u with respect to x is what? It's just 3. So we have 3. Then from here we can find what? The dx, saying that dx, by making dx to be subject to be 1 over 3, then what? Du. So we can come back to here and substitute the value of what? You can come back here and substitute the value of what? Dx. So we can say our integral is equal to u raised power 4, then our dx is here, which is what? 1 over 3 du. 1 over 3 du. Here is no x, it's just u. So we can then say our 1 over 3 will be out of the integral. That's 1 over 3 integral of what? U raised power 4 what? Dot u. Since we have a u and then the u, we can then the same, you can just apply what? The integral method to express the integral. Then we can say integral of this, you can say u raised power 4 plus 1 all over 4 plus 1 then plus c. So we can then say 1 over 3 that's u for 5 all over what? 5 then plus c. And then we can also say what? 1 over 3 times what? 5 u raised power 5 plus what? 6, which is equal to what? U power what? 5 all over what? 15 plus c. But remember, our value of u should be what? Substitute. We have a u as what? 3x. That's, we have the value of u here, so we can substitute for the u, saying that u is equal to 3x plus 2. That's 3x plus 2 all over what? 15. Here we have raised power 5 then plus c. So this is how the question should be solved. Then there is a shortcut method for solving such equations, that is x replaced by a linear expression. So the question initially is what? But before showing you how to do the shortcut, let's take another question so that you will be able to understand the concept very much. So another question is given. That's question number 2. Question number 2 is to just integrate what? 4x minus 3 raised power of what? Raised power of 2 then what? Dx. So same procedure, we can integrate this. Since it's a linear function, we can say let u to be equal to what? 4x to be 4x minus what? Minus 3. So since our u is 4x minus 3, we can then come back here and substitute. We can say integral of what? U 4x minus 4 is u. We can say u to the what? Yes, no x, it's just u. That's u square then what? Dx. So but here is u, here is the x. There is no way you can solve the u with respect to x. Then you can what? Differentiate this in order to find dx. So we can say du with respect to what? X. From here, since we have u, we have x here, we can find u with respect to x. So we can, if we differentiate this, differential of this with respect to x is just what? 4. So from here we can make this dx to be subject of formula so that we can put it here. So from here we can say du is equal to what? 4 dx. So we can make this to be subject, saying that dx is equal to what? 1 over 4 du. So since we have the x, we can replace it here, saying that integral of what? U square, our dx is what? 1 over what? 4 du. So from here we can take 1 over 4 outside. That's 1 over 4 integral of what? U square what? Du. So since we have u with respect to u, we can then integrate 1 over 4 integral of this. That's u 2 plus 1, that's 3 all over 3 then plus what? C, which is also equal to what? 1 over what? 4 times what? 3, that's 4 times 3 u raised power of 3 plus what 6. Then we can say we have u power 3 all over what 12 plus c. Our u power 3 is what? We have u as 4x minus 3. Then we can say 4x minus 3, that's the u. Then we have our 3 here. Then we can put our 3, then all over 12, then plus c. So the answer should be equal to this. So since we are going to show you how to do the shortcut, so it is very easy. The question is here. That's the questions. The question is what? The question is what? Integral of what? 4 x minus what 3 then dx. So to do the shortcut is very simple. What you need to do here is there is a square here. So to do the shortcut is very easy. Just what? Take the differential of this, inverse of differential of this, meaning that the inverse is just 1 over the something. That's the inverse of this. So differential of this is 4. So the inverse of 4 is equal to what? 1 over 4. So we take the what? Inverse of the differential of whatever in what linear expression. So the differential of this is what? 1 over 4, is 4, and then the inverse is 1 over 4. And then take this one, the whole this, and then take the whole this. Let me change the pen. And then since at the beginning you take what? You take the differential of this, that's 4, and then you what? You take it is inverse, that's what? 1 over 4. And then take the whole this and then do it the way you integrate. So we can also say that this we have 4x minus 3 to power of what? 2. We can then integrate, that's plus 1 all over what? 2 plus what? 1, which is also equal to 1 over 4. Then here we have what? 4x minus 3 raised power of what? 3 all over what? 3. Then we can say 4 times 3 is what? 12. Then we can say 4x minus 3 all power what? 3 all over 4 times 3 is what? 12. So as you see here is what? Equivalent to this. So it's the same. Let's take a look at the first question. So the first question, the answer is here. So we are going to take the shortcuts. So the question initially is to just what? Integrate what? 3x plus 2 raised power of 4 dx. So all you need to do to just what? Take the what? Inverse of the integral of the expression, linear expression. So our differential of this is what? 3. The inverse is 1 over what? 3. It's 1 over 3. Then take the whole this and then do the integration. So you can say 3x plus 2 then power 4 plus 1 all over what? 4 plus 1. So here will become what? 1 over 3 times what? Here is what? 4 plus 1 is 5. Then our this will become what? Here we have 3x plus what? 2 raised power of 4 plus 1 is 5. So luckily the final answer will be 3x plus 2 all over what? Raised power of 5 all over what? 3 times 5 is what? 15. So as you see they are equal with this one. So this is just way. So if you like you can proceed with the shortcut, or you can use the normal formula to evaluate the such integral. So let's take the another question. Another question is what? That's question number 3. Question number 3 is what? It says to integrate what? Cos what? Cos 3x. So what we are familiar is just what? Cos x. That's integral of cos x is equal to what? Sin x. So since we familiar with this, we can also say let's u to be equal to what? 3x. Since u is equal to 3x, then our this thing will become what? Cos what? U. So here is u, it's not x. since here is cos u, we can integrate this, but here is with respect to x, also here with respect to s, so we can't integrate this. Then we can do the same. We can find what du by what dx is equal to what, from here is just 3, so we can find dx, saying dx is equal to 1 over 3 what du. So we can substitute here, putting the value of dx. So we have cos what u dot, our dx is what, 1 over 3 du. So we can say 1 over 3 out into integral of cos what u du. Then we can say integral of this, you already know that is sine. So we can say 1 over 3 sine what u plus what, sorry, I mean here there is c, don't forget to add a constant of integration, that's sine u plus what c. So our u is 3x, then we can say 1 over 3 what sine, our u is 3x, then plus c. So this is the way to do it, but still you can use shortcuts, since you have the what integral of what cos 3x dx. So simply means simply you can say the differential of this, differential of whatever inside the linear expression, that's we have 3x here, so the differential of this is 3, then take the inverse, that's 1 over 3, then take this and integrate, then we can say the integral of what this stop is what sine, then we can say sine what 3x, then plus c. That's how it is. So let's take next questions. The next question is let me take the next question is what is integral of what exponential of 5x e to the 5x plus 2 then dx. So to evaluate this is easy. It is the same procedure. We're familiar with exponential of x, that integral of this is equal to what, e to the x. So we don't know something raised power of 5x plus 2, so we can let u also to be equal to what, 5x plus 2, then our integration become e to the what, since the whole this is what u, then you can say u dx. So we can find dx, same procedure. We can say du with respect to what x is equal to what, 5, differential of this is 5, so we can find what du dx, I mean, so dx is equal to what, 1 over 5 what, from here 1 over 5 what du, by making dx to be subject. So we can substitute the value of what dx here, so we can then now come back and say here is dx, here is dx, so we can replace this, then we can have integral of what, e to the u, then what, our dx is 1 over what, 5 what du. So we can 1 over 5 comes out outside, then integral of u to the e to the u, then do what du. So integral of this is the same, that's 1 over 5 times integral of this with respect to u is what, integral of u to the e to the u is equal to what, e to the u. So our 1 over 5 remain, then our exponential remain, our u is equal to 5x to the what, 5 e to the 5x plus what, 2. So normally we have 1 over 5 exponential of what, 5x plus 2 then plus c, our constant of integration. So the same thing you can apply shortcut. You have what, integral of what, same thing you can apply shortcut. You can say you have what, integral of exponential of 5x plus 2 dx. So we can find what, this is our linear expression. You can say differential of this is 5, then take the inverse, that's 1 over 5. The inverse is 1 over 5, just the integral of this. So integral of this is the same, so you can take the all this times what, e to the 5x plus 2 plus what, c. So as you see, this is similar to this. So let's take another questions. So another question is integral of what? Does integral of sine 6x sine 6x minus 1 is not plus 1 all over what? All over 3. Then d what? Dx. So from the beginning we can factor out 1 over 3. You can see 1 over 3 integral of sine into 6x minus 1 then dx. If we multiply this, it will give you this. So we can just say let's like u to be equal to this, then our integration will become what? 1 over what? 3 integral of what? Sine what? U dx. So since we let u is equal to what? 6x minus 1, so from here we can say du with respect to x is equal to what? 6. Then our dx is equal to 1 over 6 du. So we can say 1 over 3 integral of sine x dot our dx is 1 over what? 6 du. So since here is u, here is u, can integrate, so we can factor out this 1 over 6 will be out. That's 1 over 3 dot 1 over 6 integral of what? Sine what? U du. And from here we can see 3 times 6 is 18. That's 1 over 18 integral of what? Sine u dot du. Then we can see 1 over what? 18 times sine u du with respect to u is what? Minus what? Cos u plus c. Then we can now see what is u over 18 minus cos u. Our u is what? Is 6x minus 1. So we can see cos 6x minus 1 plus c, minus cos 6x minus 1 all over 18 plus c. So the final answer is minus cos 6x minus 1 all over 18 plus c. So to do the shortcut method is very easy. Just take the questions. Our question is what? Sine 6x minus 1 all over 3 then dx. To do the shortcut, just take we have 1 over 3 outside from the beginning. That's sine 6x minus 1 dx. So we can say the inverse, take the inverse of differential of linear expression. That's differential of this, all this is 6, so you can have 1 over 3 dot 1 over 6 outside. Then take the integral of the whole sine. So the integral of this sine is what? Is cos, minus cos I mean. So we have minus cos into what? This. So this is what? 6x minus 1 then what? Plus c. So we have what? Minus what? Cos 6x minus 1 all over what? 18. So it's the same. So the final answer should be is equal to minus cos 6x minus 1 all over what? 18 plus c. So the next question is to find what? Integral of 7 all over 2x minus 5 then dx. So From where we can say 7, we can factor out 7, that's to be equal to 7 integral of 1 over what, 2x minus 5. So this is like similar with 1 over x, and then if you have integral of this become what, ln x. So it's just simple thing, just have to what, see the whole this to be equal to u. So the u is equal to what, 2x minus 5. Then we can now say 7 integral of what, 1 over what, u was with respect to what, x. So here is what with respect to what, x. Then from here, since we here is what, dx, here is u, then we can find the x from this expression. You can say our u is equal to what, 2x minus 5. So we can say the u with respect to x is equal to what, 2. Then we can find the value of the x, making the x to be subject, the x is equal to 1 over 2 du. Then we can now substitute for the value of x, dx, in our equation. We have 7 integral of 1 over u du. Our dx is what, 1 over 2 what, dx. Our dx is what, 1 over 2 du. So we can 1 over 2 half will be out, that's 7 over what, 2 integral of 1 over u du. So integral of 1 over u is what, ln u. Then we can say 7 over 2 ln of what, u plus c. So 7 over 2 ln, our u is what, our u is 2x minus 5, then plus c. So this is the shortcut. Let's see, if you want to do the shortcut, you have what, let me change the pen. If you have, let's see, integral of 7 all over 2x minus 5 dx. So to do the shortcut, just take 7 outside, 7, just make the equation, make the function in nested form so that you can be apply shortcut. You have 1 all over 2x minus 5. Then we can say let this to be equal to u. So here you start apply your shortcut. You can just find the differential of this. Differential of this is 2. Then you can take the inverse. We have 7 outside, then the inverse of the differential of linear expression is what, 1 over 2. That's 1 over 2. Then integrate this function, all this function. The integral of this is what, ln all this, that's ln 2x minus 5 plus u. Then 7 by 2 is what, 7 over 2. Then ln of 2x minus 5, then plus what, u. So this is the final answer. So let's take another question. Another question is here. If you have what, integral of what, 5 exponential of 1 minus 3x dx. So let's apply shortcut. We can take 5 outside, then integral of e to the 1 minus 3x dx. So we can say differential of this is minus 3, the inverse of it is 1 over minus 3. Then we can now say we have 5 in the equations, then differential of this is minus 3, inverse, that's 1 over minus 3 minus 3. Then take the integral of this, integral of exponential 1 minus 1 e to the 1 minus 3x is just the same. So we can say e to the 1 minus 3x. So the final answer will be what, 5 over minus 3, then exponential of 1 minus 3x. Don't forget to add what c. I'm already tired. That's right. So the final answer should be equal to, I'm so boring. That's why I'm exhausted. That's why the solution look somehow. So the final answer for this 5 exponential of 1 minus 3x dx, no need to apply formula all the time. You can just apply shortcut. So this stops is going to be 5 all over minus 3 exponential of 1 minus 3x then plus c. So this is the final solution. We are going to stop here. I hope you understand the concept and then the procedure. So don't forget to subscribe, give a like, comment. Thank you. See you in the next video.